Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 25 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you pour your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this incredible video tutorial series. And in this class, we are using the most excellent Sunfounder Raphael Raspberry Pi kit. Most of you guys already have your kit. If you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick up this most excellent kit. And believe me, in this class, your life and my life are going to be a whole lot easier if we are operating on identical hardware. But enough of this shameless advertising. Let's talk about what I'm going to teach you today. And we got a great lesson today. What we're going to learn how to do is we're going to learn how to connect the LCD1602 LCD display to the Raspberry Pi. And we're going to connect it to the Raspberry Pi and display text on the LCD using I2C. I2C is a communication protocol that is used between single board computers like the Raspberry Pi and certain components. Now, the really cool thing about this, it allows us to connect to the LCD display using only 4 wires. Now, back in the day when I was teaching in high school, these things did not just have 4 wires. They had like 27 pins, and you had to plug it into your breadboard, and you had to perfectly make 27 different connections from the LCD to the Arduino, which I was teaching at the time. And believe me, it was this project that separated the engineering students from the culinary arts student. There was more than one student who ended up just giving up, leaving engineering and going into culinary arts. But good news is now it's a lot easier because you can do it with I2C with only 4 connections. Hey, that's invisible. It's invisible on one side. Okay, so anyway, that's what we're going to be doing today. And enough of this chit chat. Let's jump in and let's see if we can get this thing hooked up. Well, let's pause and watch the fishermen drift by. Dual fishing boats, dual fishing boats. And I think we've got Island Boy over here in a red shirt. You can see it looks like he's casting his nets. Am I easily distracted or what? But I don't know about you. Leave a comment down below. Are you tired of hearing about the fishermen, or do you love seeing the indigenous fishermen drifting by, catching their Nile perch and tilapia? Okay, enough of this nonsense. Let me get out of your way. And then you can see back there that you can see that floater on his net there. But again, I digress. Let's come over here. And what we're going to need to do for this project and to get this whole thing hooked up, you're of course going to need your Raspberry Pi. Then from your Sunfounder kit, I've got this 40-pin ribbon cable, and then I have it plugged into the Sunfounder breakout board. And I just find it's a lot easier to do these projects if we connect through this breakout board than trying to connect things directly to the Pi. So I usually in most projects go ahead and do it this way. And then what we're going to do is, I probably need to get this out of the way, we're going to go ahead and hook this up. Now you might see some extra wires on here. I usually leave my board set up where I power up this top row as a power rail at 3.3 volts, and then I ground the bottom row with the ground pin, and then I connect I jumper power rail to power rail, and I jumper ground rail to ground rail, and I usually just leave this hooked up, so I just start with this as a starting point. Now the key thing I got to tell you though is remember that we usually leave this power the power rail at 3.3 volts. This device is going to require 5 volts, so we don't want to connect to the power rail. We want to connect to the pin up here in the upper left, which is 5 volts, all right? But let me turn this over, and the nice thing is, I guess I need to turn it this way where I can see things. Yes, I can see things when the pins are pointing to the right. I can see things, and let's go ahead and let's hook up 4 wires. And the nice thing is this is labeled, so the top wire is ground, or the upper one is ground. When you have the pins pointed to the right, that's ground, so I'll use brown for ground, brown for ground. And then the next one is VCC, and so I'll use red. That's going to go to 5 volts. And then since it's red, I will go red, green, blue, just because I always remember things in that order. So the SDA is going to go to green, the SDA is going to go to green, and the SCL is going to go to blue. Okay, so now we've got that hooked up. Now we've just got to hook the wires up. We have to be extra special careful to get these things hooked up right. But now red, let me do a little detangling here. Red is going to come up to this upper left pin, which is 5 volts, and so that's good. Ground is always ground, so I can connect this to the ground rail. Is that the ground rail? Yes, that is the ground rail. And so I will connect that to the ground rail, and boom, boom shakalaka. Look at that. We already have power, and so this thing is kind of powered up. That's kind of encouraging. Means that we didn't get a dead brick in this thing. It's showing signs of life. All right. Now the next one, what was the next one? The next one was... The next one, green, is SDA. Green is SDA. And if you come over here and if you look carefully, right down here is the SDA pin. So I'm going to bring green into SDA. For me, it looks like the third one over. No, it's the second one over. SDA is the second pin over, and then SCL is the third pin over. Now you can look and read it directly off of this. So read it directly off of this. It's just I'm kind of a foot away from it. If I stuck my big head down there, you would not be able to see. You would not be able to see the connection. And so just look on the back. SDA goes to SDA. SCL goes to SCL, 5 volts to power, and then 5 volts to power, and then don't forget to connect the ground. So I think we are connected up, but in order for the world to be in, universe to be in proper order, we must keep this thing square. It's a little bit crooked. Perfect. But of course, if you're OCD, nothing is ever perfect. Okay, good enough, which is hard to say. All right, so now I think we are ready to move on over to the Raspberry Pi. So we're going to switch over to our Raspberry Pi view. And before we start coding, there is a little bookkeeping that you are going to need to do. And I need to do a little real quick bookkeeping here before I do this. So give me a second. You can sit and enjoy the fisherman out there while I am going to have to prepare my Raspberry Pi for this lesson. So give me just a second. There was one little thing that I didn't do. And so let me... Okay, the Raspberry Pi is ready to go now. And before we jump in and start coding, we've got to get our Raspberry Pi configured for two things. We've got to get the library that allows easy use of the LCD1602. We've got to install that library, and then we have to configure our Raspberry Pi for I2C. Now the good news is I'm going to show you step by step. It's very straightforward, but you just got to do things exactly like what I am showing you here, and then everything will work. It's just what you're always going to see is everything that we try to do is just it's a little bit more, let's see, it's a little bit more tedious on the Raspberry Pi. Things are a little bit more tedious on the Raspberry Pi than what they are on the Arduino. But the good news is I show you these things step by step, and then it should be fairly straightforward for you to do them. So let's see, we're here at the Raspberry Pi. What I need you to do is call up a terminal, and there is our terminal. And what I need you to do is a sudo raspi config, and then this pops up, and then I need you to come down to interface options. Okay, and then I need you to come down to P5 I2C, and then would you like to arm the I2C interface to be enabled? You need to click yes. Okay, and then it says it's entered, then I click OK, and then after I click OK, I come down, 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 and then right over. Notice you've got to use your up and down keys. The mouse doesn't really work on this, and so you come over to finish. Okay, you come over to finish and enter, and boom, we have this thing ready now to do I2C. Okay, now what we need to do is we're going to have to install some libraries and get some things going. And so what we are going to need to do is we are going to need to, let's see where this is. Okay, we need to check whether that actually worked. Even though that it said it worked, we're going to check and make sure it works. So we're going to say lsmod, and then the shift/, which gives you the vertical line, and then we need to do grep, which is going to look for this grep, and then I2C. So we're going to see if we have our IC2 module loaded, and boom, you should see something like this, I2C underscore BCM 2835, and then your number might be different, but you should see IC2 underscore develop, but your number might be different. But basically that just shows that it works. If you don't get this or you get an error, reboot your Pi. Okay, if that doesn't look like it's working for you, go ahead and reboot the Pi. But for us, it's working. Now we've got to install the I2C tool. So we're going to do sudo apt-get install, and then you want I2C-tools. Sudo apt-get install space I2C-tools, and then boom, look at that, it's finding it. And for me, it said it was already there. Yours, it might say it was already there, or it might go through an installation, but either way, now we have it. And that was the whole point, wasn't it? Okay, now we need to look and see what the address is of our I2C device. We've already connected it over there, so now let's see if it has given it an address. So you need to have things wired up and connected before you do this, but I'm going to do an I2C detect, and then -y, and then for the Raspberry Pi 2 and higher, you put a 1. If any of you are using a Raspberry Pi 0, my condolences, but you would need to put a 0 there. Okay, if it's a Pi 1, you need to put a 0 here. If it's a Pi 2 or higher, you put a 1. And so let's see if it detects it. Boom, look at that. Now what this shows us is it shows us the address. And the address is like on 20 and 7. You see 20 and 7 is 27. That is the I2C address. Make note of that because we'll need this in a minute. Our address is I2C. Now we are going to need to install a few more packages. We're going to need to install a few more packages. So I'm going to come over here and I need to do a sudo apt, make sure you guys can see that, apt-get install, and then lib, L-I-B-I 2c.dev, and I am going to get out of your way before you yell at me. Okay, so sudo apt-get install libi 2c-dev. Now let's see what happens. Okay, it's getting it. Do I really want to install it? Yes. Okay. Okay, set unpacking good, setting up good. That went through without an error. Now we have to do a sudo pip3 install, and it's important to do pip3 because that will put it on Python 3, and that's what we're doing these lessons on. If you just do pip, it'll put it on Python 2.7. Little pro tip there. And what we're going to need is smbus2, smbus2. All right, so we're going to click that, and it's out looking. We get nervous. It's collecting. That's good. Installing collected packages, successfully installed, and so that is good. So all that we have ready to go. All of that is ready to roll. And so now the one other thing that we are going to need is we're going to need the LCD1602 library. And I have put that on the most excellent www.toptechboy.com, and you can actually open this on your Raspberry Pi, and then you need to use the happy little search tool here or the search tool here to search on library for I2C connection of the LCD1602. Search on something like that, and you will come down here and get this. This is the library we are going to use. And what we can do is just come up here to this icon, click on it to copy. It says copy to the clipboard. That's good. Now what we need to do is come over and open up Thony. Okay, and let me get rid of that, or let me just close that. And then what we're going to do is new. And then we are going to save this as, LCD1602.py. Okay, it's important that you save this in your Python program folder, because when you load the library, it's going to look in that folder. So if you're going to, whatever program you're going to write your LCD program in, this library needs to be in that same folder. Or let me say that again, that wherever you're putting your LCD.py program, whatever folder you're putting that in, you need to put this in the same folder. All right, so hopefully that makes sense and I didn't confuse you too much there, but we're going to save it. Okay, so now, okay, we've saved it. Now I come here, I created the program. Now we come here and I Control V to paste it. And now I got to save it again. This time I just got to say save. All right, and it's in my Python folder. So we should be good there. Sometimes I lose my cursor. All right, there it is. So now that that program is saved, now we can close this like that. Okay, now I'm going to create a new program. And I am going to save the new program, and I'm going to save the new program as not untitled. I'm going to save it as LCD display.py, LCD display.py, and then I'll click OK down there, and now I am good to go. Now I'm going to show you the hard work is done, and now it's going to be pretty easy to use this. All right, so the first thing we need to do is import the library we just created. So we say import LCD1602, like that. That's easy enough. We're going to import time. We are now going to initialize the LCD1602. So I'm going to say LCD1602.init, and then we do 0x27, which I think is how we write the address, and then we've got to tell it to turn the backlight on. So we will put a 1 there. So that should be pretty good. And so that thing is initialized now. And so now I'm just going to create a loop. So what I'm going to do is I am going to say try like that, and let me get over here. I got a little ahead of myself. Okay, I'm going to do a try. And then what am I going to do in the try? I'm going to say while true. When is true? True. True is always true. Now we always want to exit our programs cleanly, so I'm going to say except, and except on keyboard interrupt, keyboard interrupt like that. And so it'll sit in loop until it sees a Control C. Then it will jump down to the accept clause. And what do we want to do there? LCD1602.clear, like that. And then I'm going to print, just to see that I got here, I'm going to print LCD good to go. So I'm kind of cleaning up that LCD. Now what do we do up here in the while loop? Well, I'm going to write to the LCD. So I'm going to say LCD1602.write. So I'm going to write to it. Now, what do I want to write to it? Well, the first thing I have to say is where I want to write. I want to write at column 0. So if you look at that LCD, let me come back over here and show you this. Okay. If we come back over here, there are 2 rows and there are, I think, 16 columns, and that's what the 1602 is. It's 16 columns and 2 rows. Now, what really bugs me in math when you're dealing mathematically with matrices, it's always row by column. Row is always first. But here in the LCD land, it seems like you put column first. You put column first, 16 columns, and then 2 rows. Okay, so a little bit backwards from how things are done in math. But let's come back over to our code view. And so where do I want to write? I want to write on column 0 and row 0. So that will be column 0 is on the left and row 0 is on the top. And so that's the top left column. And then what do I want to put there? I want to put hello world, like that. And then we close that. And then I'm going to do an LCD1602.write. And I'm going to say, this time I want to stay in column 0, but I want to go to row 1. So it'll be the second row. And then what I'm going to say is, what should I say here? I think I will say welcome, something nice like that. Welcome. All right. Could it really be that easy? Could it really be that easy? So let's see. I think that looks pretty good. Let's go ahead and run this and see what happens. So I'm going to hold my breath. Oh, welcome. I didn't close my quote. All right, hopefully you guys saw that. It is the fault of whichever one of you it was, and I think you know who you are, that did not hold your breath. Let's go again. Boom, it's running. And let's come over here and let's look at what we got. And denied, blank screen. How many of you guys had this happen? Now, leave a comment down below. Same thing happened to me, or no, it's working for me, or hey, if I look closely, it looks like it might be working. Okay. Now, what is happening here? What is happening is it is actually there, and if I look at an angle, you can kind of barely sort of see it. But what is the problem? The problem is the backlight is too bright. And if you look on the back, there is a secret hidden potentiometer, a secret hidden potentiometer, and you need a freakishly small screwdriver to change this. But I have a sort of broken tweezer end here that will fit down in there, and so I'll try to put it in there. Make sure when you're using metal around a circuit, and wow, I just unplugged SCL and SDA. So let me go ahead and put those back in. So I've got green is SDA, green is SDA, and blue is SCL. So I'll put those back in. All right, we're back there. That looks good. Okay. And now what I need to do is I need to put the screwdriver, the tweezer, whatever you have, and then I'm going to turn it counterclockwise to turn the light down. until it displays really well. Boom, look at that, perfect. Shazam. Okay, so you adjust yours where it is working correctly. All right, let's then let's see if our I'm going to hit a Control C, and when I hit a Control C, okay, this is looking good, but it doesn't look like it's clearing the screen. Let me try it again. I'll run it again. Okay, and then we'll come over here and look. We'll come over here and look. And now I will hit the Control C. The program quits, but that stays up there. So we got a little bit of an issue here. And what I am betting is you're sending commands over to the LCD. It could still be executing that last command, and then it doesn't see the clear when you're down here. So I'm going to try to help with the timing time.sleep. So when we do the keyboard interrupt, it'll give it a second to finish whatever it was doing. And let's say 0.2. like that. All right, so let's see if that'll fix it. I'll come up here and run it. All right, we'll come back over here and see what it's doing. We've got the hello world. Now I will hit Control C and the screen is clear. So just understand, if you're hammering that thing too quickly, you might come up with a little bit of a timing problem. That one surprised me. I wasn't expecting that, but then I was thinking, you know, it's got to be trying to hit things too quickly. And so what we've learned are the basics with the LCD. You can control what position you want to write in columns and rows. You can control what you want to write, and then you can clear the screen. And so those are really the big things that you actually need. Okay, guys, man, that was a great lesson, and I love being able to hook that thing up with just 4 wires. That is really cool. Time for what? Time for what? Time for your homework assignment. Time for your homework assignment. And what I want you to do is, first of all, this homework assignment will help review the things that we have learned so far, and then it will also allow you to start doing some more complicated projects that have sensor input, user input, and then display. And so what I want you to do is go back to your most excellent DCT, is this the DCT11? I forget what this is called, but your temperature and humidity sensor. And what I want you to do is I want you to hook up your temperature and humidity sensor, and then I want you to have one of those little toggle buttons. Okay, I want to have a toggle button on your project, and then I want you to have your LCD display. And what I want when you run the program, I want you to display the temperature in centigrade. Okay, the temperature in centigrade on the top row, and then on the bottom row I want you to display the humidity. But if you press the toggle button, then what I want is I want it instead to display the temperature in Fahrenheit and the humidity. So if you push the button and release, it's going to go from centigrade to Fahrenheit. Press and release again, and it goes from Fahrenheit back to centigrade. So you have a toggle button that controls whether you are displaying Fahrenheit or centigrade. Okay, and then also, you know, make it look nice, make it nicely formatted. Then you're to post your homework solution to YouTube. In the description of your homework solution, leave a link back to this lesson, and then in the comments below, link over to your homework solution and show that you guys have this done. Okay, this has been a really fun lesson. I love it that we're starting to bring components together, and I think that this homework assignment is very doable for you, but it'll help you review the things that you've learned in the earlier lessons. Guys, I hope you're having as much fun taking these lessons as I am making them. If you like the lesson, give us a thumbs up. If you haven't subscribed to the channel already, make sure that you subscribe. When you subscribe, ring that bell. And then most importantly, share this with other people. You older guys, find a young person to get into this. Let's see if we can get more people interested in this, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.